Okay, I think we are live. Well, good morning, YouTube. Slightly unannounced stream today. Peter and I are deviating a little bit from our regular schedule of like last Friday of the month because it's the middle of summer and school holidays with kids and family events going on has made it a little bit harder to schedule than usual. So, in a little bit of chaos, we're here this morning. I'm ready to go for proceeding with our work on Unicode objects. For a recap, we should probably refresh our own memories as well, Peter, on where we got to. I think we have a commit on benchmarks. Yeah, we got to a point where we had a working compile of CPython. We haven't rebased this on CPython main for a while. I don't know whether
hopefully Unicode is not changing that much.
actually, it's rebase. It's based on July the 3rd. Python. It's not too bad. Yeah, it shouldn't be conflicting, I guess, but we can work it out as we go. We got a working compile, and in that working compile, we have changed the way that Unicode objects work so that we have the capacity to store what we call the surrogate escaped Unicode UTF-8 buffer. So UTF-8 with some extra possibilities for surrogate escapes in there. And this is possibly for language interop going to be the primary way that data is represented. And we wanted to then also look at benchmarks for UTF-8 performance from text. And I vaguely recall, I can't remember how we did it at the end of last stream because it's a month and a half ago now. We were beginning to look at the PyPerformance suite.
There's a run benchmark.py, and I think we installed PyPerformance.
Yeah.
Try if you still have that in your shell history. Something like PyPerformance.
Here we go. That's what we got.
Ah, yes.
And we found that the new paths were slower, which was not an entire surprise because we've added a whole bunch of lazy stuff and branches, and we didn't try very hard to optimize yet.
Right, it's basically doing everything the old code did.
And we gave it a Python to run. And I have my main branch, probably at the same commit. So we ran that. Now the only question is, what is benchmarks.conf? So what did we actually run? We ran one benchmark, which was doing a UTF-8 copy.
We copied a French book from one file to another.
Yes. Which hopefully has, Unicode characters.
It's not ASCII.
Yep. Okay. So the next thing, and I remember we were talking a little bit about potentially wanting to do flame graphs on this benchmark so that we could learn.
Right.
So that we could learn where the hot path is and try and optimize benchmark as a little bit of playing around. I think that was going to be our next step. Should we proceed with that?
Okay. Do you have any experience running profiling C code?
Yes.
Great.
So hopefully we have, this is hopefully our Python interpreter running. I assume that I haven't rebuilt it since, so I'm going to trust that this is the same one that the PyPerformance ran with. So we can do a few different things, I guess. I tend to use a Rust-based helper, which I think can do native binaries just fine. So I'm going to start by trying that and see what happens.
Sounds good.
And so if we just do Python,
So just for context, Python has some profilers, but they're targeted at Python code. So
yes,
they, as far as I know, they will show you things at the level of Python functions. Uh, and for copying string data around, that's not really the level we want to be at. So we probably want to use a native code profiler.
yeah,
And Python should have all the necessary hooks to uh, for the data to show up. So I know Pablo has been working a lot on
yeah,
the low-level details, adding trampolines, things like that.
hmm
So it has stuff like all the Python functions don't show up as the same thing in the flame graph. Not that it really matters for this benchmark.
yes. There's a
Fine.
Python perf support environment variable or something like that, isn't there, to enable the trampoline? I vaguely recall.
I think it's on by default
Oh, it's
now.
on now. Okay, fine. That would also
Oh,
work fine. Okay. Let's first work out the command that we want to benchmark because we were running it through the PyPerformance shim with UVX on top, so that was quite wrapped up. I think we probably want to create a virtual environment first because we're going to want to have PyPerf installed, which is from PyPI, right? So
I don't think we want to wrap it in PyPerf.
Let's
We
think about
just
this.
want to run this snippet.
Yes. I mean, I guess what's PyPerf going to do? It's just going to loop it a few times. Yes, that's not necessarily going to help us, is it? Okay, sure. So we could have. Let's restructure this then a bit. Yes. Take this. Copy over to here. And then we'll just do our usual, I guess. Name a. Oh, with some imports missing. Copy those over as well.
Or maybe just IO. Yeah.
Well, and the just constant. All right. So now. Fine. That seems like it's probably done it. Let's just do some print just to convince ourselves. Yep.
Nice.
Okay, so let's leave the print. No, it can't hurt. All right, so I usually reach for a tool called well, I install one from FlameGraph or from Cargo often, which I haven't got right now. I think I'll just go install it.
What's binstall?
No, that's not worked. I'm going to have to remind myself. Binstall is just installing pre-built Rust binaries. I think I've got the name of it.
Like it's just FlameGraph? At least something else.
Yeah, probably. Yeah. Let's try that. Yep, that looks like it's going to install what I expect. There we go. So now we have FlameGraph. And so I think if we just give it our Python string, this. Oh, then I've got My kernel's telling me no. Normally you can turn this down a bit. I'm just going to.
You also missed a dot in the binary names.
Oh, yeah. Oh, that would help. Okay.
Okay, what is this telling us? Consider adjusting proxys kernel perf event paranoid.
I think it just need to set.
Put it to -1.
Could do. Yeah. It's currently set to 4. Just try turning it down until it works. Okay, let's try 2. Perhaps. Oops.
I probably want to echo 2 and sudo t.
Yeah, it looks like it's somehow not worked. Okay, yeah. That?
Yep. So that runs echo under root, but not the shell. So you want echo 2.
Oh, all right, yeah.
Sudo t.
Yeah, of course. Let's try that. Okay, that seems to work. Let's try again. That's better.
Ooh, wow. Okay, let's see that.
So hopefully, if I'm really hoping that Z is able to display this now. We should have in this file, this directory, flame graph.
.svg. I saw it in the file list.
Was I just completely blind?
Yeah.
No.
Oh, there we go.
Okay. Aha, that's better.
Ooh, nice. Okay, I can't read the font there, but
yeah, let's make it a bit bigger. Okay. I think it's going to be more interesting if we can open this in a browser. So let me just fight with OBS for a minute, and we'll add a browser window here.
Can you zoom in here? That might be enough.
No, I can't figure out a way to.
Okay.
Nope.
Well.
We can.
I mean, okay. If you let it stay for a bit, it
It's
gets
unblurring.
clearer a bit.
Yeah, I'll see if I can get a browser window working while you're staring at that.
Right. There's a bunch of imports, so you probably want to run that thing in a loop.
Yeah. Oh, yeah, of course. Yes, that makes sense. That would be a very good idea. And that will also give us a better signal for the number of samples that it can create of the actual loop itself. So, right. Let's see what happens if we do this.
Ooh. All right. That's visible.
How visible are we talking?
Well, it's cropped, but I can read the text.
Okay. Oh, it's gotten too big. Yep. Right, that's fine. Let's do this.
Almost. There we go.
Okay, and if we put it
Good, great.
about... Wow, streaming software. Incredible stuff. There we are. Okay, so now you should be able to see this as I click through as well. But we think we want to rerun our benchmark in a loop first. Okay, so I think I can do some magical stuff here. Let me just... I don't know if it's working. But I've not done. Right, okay, so I think if I do this... There we go. So now you should be seeing Z.
Yep.
Do this again. Oh, let's edit our benchmark first. Okay. So we can do this for... Let's do 10,000 and see how long that takes. And then we can run our benchmark again.
That's
maybe two. Looks like it. Let's dial it back by a factor of 10. Okay, that seems about good. And now, if we go back to Firefox and that very different looking profile.
Yep.
Which is almost all in Pyron main.
All right lines.
It's really all here in right lines. So we have
Unicode from UCS 1.
Some
reason.
Oh, interesting. So we're doing conversion. We shouldn't be doing that. Unless it's when it's
not. Well, if there's a chunk in the text that's
ASCII. Yeah, could well be.
Oh, yes, one that's Latin one. That, yeah. So that would be French. Maybe we should use a different language that's not Latin one.
Well, we could go peek at text.io wrapper read line and see if it's trying to do something smart. Because it might be, and that might be really confusing our benchmark, right?
Hide the flame graph.
Here we are. Oh, yes, of course. Thank you. Yeah, I was trying to configure OBS to automatically switch between the browser and the flame graph as I switch window, because otherwise I will forget every time. But
I'll tell you.
I'll figure that out for next week or next month. Okay, so this is text.io wrapper read.
Or you could share the whole screen.
That'll make things have weird aspect ratios and too small, I think.
Okay.
So it's probably not going to work very well. And we'll just stick with this. Because I've got one of those ultra wide monitors. It won't fit very well on there. Okay. Text IO wrapper read line. Get some data. Look.
Chunk. That's the main thing, I guess.
Let me.
Now here, I think it already has the line.
Yeah, it looks like it, doesn't it? Well, line. It's setting it here, but from decoded chars. Did that show up in our benchmark? Text wrapper read chunk. That looks like an interesting one. This was the other meaningful part of the benchmark. Is just calling read.
So I think our benchmark iterates over lines. So there's a bunch of code that's looking for new line character.
Oh, yep. Yeah, pi incremental new
Could we
line.
maybe read it in chunks?
Yes, that might be a good idea.
Yeah, iterate. Yeah, well, true.
Oh, because we're just open, we'll.
Now we just open it and then do write lines, which iterates over f, so that iterates over lines.
Yeah, so we could do something. We can, instead of iterating, we could do chunks. Yeah.
Yeah.
I mean, it would be.
Just probably a while loop. While true.
Yeah, it would be nice if. I guess we could. We could. Yeah. Well, we could. I'm just thinking it would be nice if this path, which seems like the obvious path for users, did the fast thing too. I'm sort of reluctant to change our benchmark, which was the thing that we wrote. It felt obvious to not hit this, but I guess I'm just looking at the benchmark again. It goes to this function: pi incremental new line decoder decode. Before we change the benchmark, let's just convince ourselves that.
So yes, this will be a good benchmark in the future, but it goes through a bunch of code which we will need to change, but I don't think we need to look at it right now.
Yeah, because you can see here it's
We
doing pi Unicode
want to
new.
benchmark more low-level stuff at
Yeah.
this point.
Okay, you've convinced me. Because yes, we don't really want to change this.
Maybe comment it out. And,
Yeah, okay. We do make this based add two. Okay, so while true,
chunk colon equals or that's the old way of doing things.
Sure, I prefer the walrus.
Yeah.
Does that doesn't need to worry about the partial right, does it? I think the assert will trip. We should be able to just run that.
The chunk too big, maybe.
What do you want? 1K?
How big is the file?
700K. That's okay.
So probably fine.
Okay, let's do the flame graph again. Okay, I will show you the new one.
It's the same, right?
Does.
Okay, so what do we have here? Text wrapper read chunk.
Still going through text.io rapid code. Why?
Well, it needs to do that. It needs to decode from UTF-8 to Python server. I haven't really changed that.
Oh, this is different though, because it's not got the other side of the PyUnicode from UCS1 piece. Just got the chunk reading. So we're still going through the same pathway. Okay, so why does text.io wrapper decode need to get a new line?
What is PyIncremental new line decoder anyway?
If the decoder is a PyIncremental new line decoder.
Can you hide the flame graph?
Oh, yes, of course. Sorry. So there is a decoder inside the file object, which is a new line. Is that going to be depending on whether it's in text mode or binary mode?
Maybe.
No, because it's a text.io wrapper. What is PyIncrement? And I'll go to hang on. Read universal.
Oh, it's translating new lines. And it's
Oh.
translating all kinds of new lines into /n.
Oh, right. It's doing the smart thing. Okay.
Okay, well, that's more things we probably don't need.
Yeah.
So open the file with new lines to /n.
It will be one of the args to open, right?
Yes.
We want new line equal.
New line equals a string with \n.
It seems surprising that the new line decoder applies when reading chunks, but fair enough.
Well, it always applies.
Oh, because it needs to
reads the
translate
content
them.
of the file in text mode, but gives you Windows style new lines as
Yes.
C style new lines.
Yes, because it needs to convert them. That makes sense.
Right.
Right. So what we need to do is we need hard code. It looks like from reading the docs open, if we do new line equals
\n.
Yeah, we just need to force it to be a particular form. Okay. then we get away from all that. And now we're just looking at raw performance of.
Can you show the browser again?
Yep. Yep. Where did OBS go? Here we are. So now we're looking at this bit, which must be the writing side.
And that's reading. Yeah.
And then this is the reading side. So it's mostly falling into UCS1. It's still doing a UTF-8 decode. Which do we care about here? Possibly.
So ideally, we would want to get rid of that.
Yes, because
We
the
just want to
motivation.
store the UTF-8 and write it to the file as is. Don't go through detection of what kind of format this needs to be in. Probably one of those things that are elided here. And then the UTF-8 decoding.
Do we okay, yeah. So it's codex UTF-8 decode is how we get there. And that's come from text.io rapid decode is just falling through some codex module stuff, presumably.
Yep.
Oh, I need to hide this again.
And that calls Unicode decode UTF-8 stateful.
Which was because it's going to use a because it's using a specific error handler. So this will trigger decoding. And that makes sense, really. If you're in the codex module asking for code.
Yeah.
I don't think we want to change.
Yeah, I guess this will need to detect errors.
Yes. And do we always need to do that at this point? Probably yes.
Yeah. Otherwise, we change semantics. I mean, the thing we can make faster is decoding with a different error handler. If we set the error handler to surrogate escape, make that faster, well, it's probably not worth it. Yeah, so we need to detect errors.
Yeah.
Yeah.
Cool. So that went to Unicode decode UTF-8, which was it's always going to do the full decode. And I think it gets to a point where it populates the UCS1 buffer as well, right?
Right.
And yeah, which I guess makes sense.
So, should we benchmark the most low-level code path, which would be the surrogate escape error handling
Because
to see how fast we could theoretically make.
because you're saying that in the current path, it does all the decoding from a surrogate. Is this from a surrogate encoded string into
Now this is from UTF-8.
right into a surrogate encoded form?
Right.
So in that pathway, if there are no errors, we should expect to run through the buffer once and then just copy it into the new buffer.
That should be a straight mem copy without any change.
Because we apply the checks lazily later.
Well, then we should also write it with the same error handler, so we just mem copy there as well.
Maybe let's talk through it, make sure that we understand. So let's go find that code path.
I don't think it's special cased. I don't think we'll find it in the code.
Okay. Talk me through where you think we need to be benchmarking and what we can.
If you go to the benchmark and open the file with errors equals surrogate escape, which is the low-level format we've chosen for our strings, the new storage format for Python strings. And what does this do then? So IO string IO. String IO. Does that have errors as well?
So this is still going to get to the UTF, the same decoding function.
Yes.
Yeah. So we're
but
still.
If it's surrogate escape, it shouldn't have to do any checking.
Go
through the string.
Is that true? Do we not need to check the code points still at all?
Yeah.
Okay, we're gonna have to think about this. Well, I'm gonna have to think about this at least. So we have this, and then if we take our file and we put invalid binary data in it, then surrogate escape will be transforming that binary data.
Okay, I think we chose the wrong name in our previous commit. Surrogate escape is probably not the best name for the low-level storage for Python strings.
Okay.
Because what we're storing is bytes. And we want to store the bytes that we read from a UTF-8 encoded file, which are possibly not valid UTF-8.
Okay. And if they are not valid UTF-8,
and if they're not valid UTF-8, you can get a Python string out of them.
yeah.
By treating it as surrogate escaped data. So if you would write the string with the circuit escape error handler, you would get the same bytes in the resulting file. So the circuit escape error handling is supposed to preserve the underlying bytes when you round trip through a Python code string.
Yeah. Could we maybe walk through an example, like in bytes term, so we can see that transformation in our heads? So let's like make a raw file which has data which we would make, which makes that transformation clear to me. If we have raw is some bytes, and now we need something that's not a valid Unicode sequence. So Copilot produce something. Okay. So hopefully that should crash, right? Sense. So now if we instead do re-encode that. Yeah, because they're surrogates, that makes sense.
For the encode, also do errors. Control Z. For the encode, also do errors circuit escape. Encode.
Sorry, on here.
Right.
I was just going to get this out. Okay, fine. So this is the.
And now print.
Yeah.
Roster.encode.
Yeah, and that's the round trip.
Yeah, and that's also need error handling. Whoa.
Okay. And so in this, we've picked the surrogate here.
Right, so this is a Python Unicode string.
Yeah, and the contents of this
contain valid Unicode.
And so the bytes here, there were 4 bytes.
These 4 bytes is what we want to store in the Python string object.
And we transformed them.
How they will be. This is how they will look to the user.
Yeah.
Right. So that's a valid Python string. You cannot write it to a UTF-8 file directly.
Yes.
But it preserves the raw bytes, which means if we're decoding using circuit escape error handling, we don't need to do any checks. We just take the 4 bytes. We know we need to store 4 bytes. We create a Python string with those 4 bytes.
Okay, so you're telling me that because at the moment, the physical format of these, we've taken those 4 bytes and we've changed them to these code points, right? DC80.
That's the circuit escape error handling.
Yeah. And so physically, what is in memory is 4 of these code points, which started as these 4 bytes.
Currently, yeah.
Yeah. And you're saying that what we want is for the physical storage of the string to just continue to be this.
Yes, so the new field we're adding should contain these 4 bytes.
Right, so it's just literally raw binary and it can be absolutely anything.
Yes.
That makes
Which is
sense.
why we have the valid UTF-8 flag, which we set whenever you try decoding this or try encoding. And that gives you an error.
Yeah, that makes a ton of sense now to me. Because I was getting confused, I remember in previous months as we were talking about this, and I was just like, but isn't the only thing we can have these code points? But I see where you're going now. So the idea is that we could store anything in that buffer,
Yes.
and if we know it's a valid UTF-8 sequence, we can do good things with it. Otherwise, I need to think about
Maybe
this.
check.
Hang on. Yes, so if we use the surrogate escape error handling, then it's okay because we can take any content and just dump it into the new field we have. And then
Yes.
when we are doing the lazy materializing the UCS1 or UCS2 or whatever, we can do the surrogate escaping then to populate the compatibility buffer, which will go away in the future anyway. But we basically treat it as if it was like this.
Yes.
And we make it look to the user in the same way, but we had to do no decoding, so it was super cheap. I understand what you're saying. And
So this
then,
is as you saw, this is a code you cannot encode directly into UTF. This
yeah,
is a Python string, which you cannot write to a UTF-8 file directly.
yeah,
This error handling.
yeah, yeah, because it's not a valid UTF-8 sequence. That's making sense to me. Okay. And then for other error handlers, we still need to do the work because those can do arbitrary things. They might well replace the content. They might well raise errors. So we can only fast path the surrogate escape one.
Yes, but if the string doesn't contain any UTF-8 incompatible bytes, then we can make a fast path for that. Right, we need to scan the string to
Yes.
find the first error to report or replace or whatever.
Yes.
But if we scan the string and get to the end, then we can just do the memcopy and mark the string as valid UTF-8.
Right. Yes. Yes. So if we
We
go
don't need
back, yeah.
we don't need to find out how long the characters should be. And
Yes. So if we go back to the algorithm, I see where we're going now. So we have, at the moment, it tries very hard to work out non-ASCII characters and work out do fast paths for ASCII and all kinds of things. Which I guess we could still have this. Because if it doesn't find any non-ASCII, we can just do a memcopy. It does it for... It makes it into a UCS1 format at the moment. That's possibly fine.
right, so the find first non-ASCII is quite optimized, and I think we'll have to reach into that. So we probably won't need to change that one to find the first non-UTF-8 character.
Yeah.
And also possibly keep track of the maximum code point.
Uh,
Oh no, yeah, we don't. So yeah, this should.
It's okay, isn't it? Because if this is super optimized for for ASCII text, which probably still a common case. It feels okay to me that we let this be here, and then this is telling us the byte position of the first thing
Yeah,
it
where we
stops
need
at. And then
right. So
and
we
then the
can
algorithm you describe, which is the non-UTF-8, could proceed from this point.
right. Yeah,
And
sounds good.
so we could leave this and we could add a new path. Because what happens next? Otherwise, it tries to. Okay, it does some code point counting.
So I think what we need here is just create the string with the UTF-8 storage and then check it.
Um, and use the error handler on the buffer. Well, but the error handler might mutate the storage, right?
Oh, right, yeah.
So I don't think we can copy it. We need to run it through the error handler. If there is
If there is one.
which is what this thing does.
Here the common path would be the strict error handler.
And the strict error handler is going to return an error.
So we should probably special case both strict and surrogate escape.
Yeah, which is well, there's a special case here for strict already, which is interesting.
Yeah. Rather than strict may remove, replace the invalid byte. And it might call arbitrary Python code, so not the fast path.
Oh, I see. This is oh, this is saying we found a byte here, which is the start byte for something, and we're checking that this is a valid start byte. If it's not a valid start byte, then we won't have this condition. So this is a fast path for the strict error handler where we think it's probably okay. But I don't know why we bothered doing that. It seems like it's a fast path to work out the max character, but we don't necessarily need that in our new implementation. All because we won't populate the old fields, we'll just populate the new one, I guess.
Yeah.
Okay. Then we've got this Unicode writer in it with buffer, and then we fill the writer. So it's going to be in this function that we're going to need to make transformations.
So can we first make the fast path for
yeah,
for the surrogate escape error handler?
I think we can do a fast path for hang on. So the fast path for surrogate escape handler would be we just copy everything always. And the fast path for valid UTF-8 is that we
Fast path for strict will be to error out on the first non-UTF-8 character.
Yeah.
But we probably don't need to add a fast path for that, really.
Yeah, I think that feels okay to.
We don't need to add a fast path for that specifically. What the new normal path would need to do is find the first non-UTF-8 character and store everything up to that point.
Yeah.
And if that's at the end of the string, that's our new fast path. Otherwise, it needs to go call the error handler.
Yeah, and that will happen inside well, maybe inside this writer, I'm not sure. Well, that's presumably where the error handler is being called at the moment, so we're going to have to look in there anyway. So, but what we do have, we have a new size find first non-UTF-8.
Right.
Which I guess is going to be something like this. So continue from, we found the first non-ASCII character there, so we can start there for our next piece of the algorithm.
Yep.
And then if we do, if pos equals size, we now have a fast path for UTF-8 strings, which we don't want to use Unicode new here, do we? We want to use, we had a function for this. Can we remember what it is? Unicode from surrogate escape.
Yeah. Oh, nice.
We wrote it already, and I think we can just use it.
Yep.
I hope. Unless it goes round. No, yeah. Yeah, this doesn't do any decoding or anything. It just does the work. So we can go here, we can go.
I can just return that, right?
Yeah. Oh, do we just, we don't even need to do the branching, do we? We just do like this.
Might come up later, but yeah. Yeah.
Nice.
So anything after that is really something we don't need to optimize, because who's reading non-UTF-8 strings from a UTF-8 file?
Yeah.
That should be very, very cold code path. That's the error case.
Yeah. I'm trying to think if there's one other. There's this. So you spoke about the surrogate escape, and if there's a surrogate escape, we don't even need that, do
yeah,
we?
we also need to set the valid UTF-8 flag right here. So the if goes back in.
Yes. Oh yeah. So we will need to assign it. Okay, so we will want that. Okay, and now we want. Oh gosh.
State.
We're gonna need.
That's a macro, so we'll typecast automatically.
This one.
Yeah, I just copy that line.
Yeah. Okay. Yeah. We can do Unicode state u is valid UTF-8 1 and u. Fantastic.
Great.
And there is another fast path. you spoke about the like we could just do this. We could just make this fast path here, I guess. There is the other fast path, which is the surrogate escaped handler, which we spoke about, which
Right.
is.
But I guess that's not a very common fast path anyway.
Yes. Well, hang on. So at the moment, the surrogate escape handler will do the decode into the code point, the physical transformation we spoke about. And so we could add a case here, which is if it's a surrogate escaped handler, we don't care and we just call this, right?
Right. So here's my thinking. So surrogate escape is currently usually used for file name. So that if you have some file name with a weird encoding on disk, it goes through the machinery and only causes trouble when you try to print the file name out. And file names are typically quite short, and we don't really optimize.
Okay.
If somebody is changing their code to do something like our benchmark, copy stuff from one file to another, and they don't want to check for indefinite validity, they can just open the file in byte mode.
Yeah.
So, yeah.
So we don't really want the errors.
Yes.
And now, okay.
Nice.
Okay. Right, so this is now not going to compile because we haven't got our find first non-UTF-8, but we could work on it. So we have this function. Let's just take the and I guess Copilot is going to get very happy and just fill this algorithm for me.
Somebody wrote that already, right?
Almost certainly.
We just take their implementation and don't worry about the license.
Well, for now we cover our eyes and hope it's fine, and then we. Oh, this looks worse than I hoped to see.
What are you doing there?
I don't know what that wants. Let's not do that then. Let's think about this. Oh, hang on. That would help. Okay. So let's think about this. Is that how is this algorithm? I don't know what these unaligned reads are. Button might not be aligned as. Oh, okay. It looks like there's some special.
Yeah, this is.
Okay. Why don't we just do the naive
let's
thing?
Let's optimize later. Yeah.
So.
Oh,
that looks more reasonable.
That's pretty much what.
2-byte sequence needs that. 3-byte sequence. Fine. We haven't written tests for it, but let's trust that at least gives us a compile and see what happens.
That has the right shape.
So now we're going to have to high performance, aren't we, again? Because that, I think. probably. Oh,
To compile first.
optimize. I think, does it have to? It's not building it, is it? Going to need to build it first. Yeah. Okay. So
Make.
the high performance.
Oh,
File, is that what we want?
maybe.
Or did we just use make?
Yeah, just use make for now.
Okay.
High performance will probably compile it with all the optimization settings.
Let's hope. Oh, we're wrong anyway. Oh,
Yeah.
oh yeah, of course, we can just do that. There's an -03 I saw in there. Oh. Oh dear. Something's wrong.
Yep.
uh, all right.
What is wrong?
We need or GDB.
Was Copilot wrong?
Did I get that wrong?
Oh, you need -args.
It's args. I always get mixed up which one's LLDB and which one's GDB. Okay.
Whoops. Oh.
Ooh.
Oh, this is because you need to preserve the old pause for the code under this.
Ah. Okay.
You need a different variable here.
Because otherwise pos is now not a non ASCII, it's also not, or it could be it's still non ASCII, but it might have gone further on, which
Right. Still getting a sick ball.
yeah, it seems surprising that that would actually, oh yeah, no, because that would be wrong, wouldn't it?
Yeah.
So that definitely is part of the problem, but we're still wrong. Okay, that's fine. We got further, did we? Yeah, we got further. So that's more promising. Copilot's almost certainly wrong, and we'll have to go think about that properly. In Unicode from surrogate escape.
Ooh.
That's nice that we are. That we're crashing, I guess. 2042 crashed here. Why? Ah.
What?
How can it crash there?
2004 by object.
But it's is it a cycle? Maybe it's a cycle. Yeah, that looks like a cycle.
Oh, PyObject new is calling PyUnicode from surrogate escape.
Why? PyUnicode. I don't know. I think we must have something else
PyUnicode
wrong.
filled data or abort
We got
is
PyUnicode data calls PyUnicode non-compact data, which calls PyUnicode fill data or abort, which calls something's wrong in this cycle. We already had a pre-existing bug that we just hadn't managed to hit yet, I think.
yeah.
Uh,
Oh, our fill data or abort is creating a new Unicode object and then copying the data over from it.
oh,
We need to fill in that functionality.
we need to do that properly, do we? Yeah.
Yeah.
Because thinking.
Well,
Oh
this
no.
Unicode decode UTF-8 will create a new Python object, which
Which is using the surrogate escape error handler, which we were just talking about. Hang on. Yes. No. No. Because we do actually need to go through the error handler in this one. We have to.
Really?
Yes, because when we're in this point, we are in a place where we have raw bytes in the in our new field, and we need to populate the old one. So we need to go through the surrogate escape to error handler to populate the fixed width encoding. And so
Well, surrogate escape doesn't do anything. Yeah, so I think we need to implement the fast path for surrogate escape right here.
No, this needs to go through the physical replacement. This is trying to create those code points. It's doing this step, right? It's going from this is what we've got. This is what we've got in a new field.
This is.
We're trying to create the UCS2 data that looks like this.
Oh, right.
So we actually do need to do some work. I think we can probably split Unicode decode UTF-8 up. Because this is with the writer, which is past our fast path now. Yeah, I know what we can do. We don't want, because we must be now hitting our fast path again and causing ourselves headaches, basically. This must be the cycle because we've added this.
Right.
And what we really want to do is we want to do the work. We know that we don't need. Ooh. Yeah, I wonder whether we could do this something. And maybe use PyUnicode writer. Yeah, probably. Well, hang on. Because this is actually doing work, and the writer is filling the old field. We might want to change in the future, I guess.
And so currently over in the fill data report, we're creating a new Unicode object.
Hmm.
And we want to change creating new Unicode objects to not fill the data. So we want to take this block that you're currently in, put that in the fill data report.
I think that's going to do it, isn't it? Yeah. I think I agree. Go back to fill data report here. I think we can do something like this. Init with buffer. U was.
Buffer is the compact circuit escaped.
U is the object. Have. This needs to abort here. Fail. Oops. My Unicode writer finish. Turns presumably. Yeah.
That failed also, fatal error.
Yeah. Same thing. I guess we could go to clean up, right?
Not just fatal error.
Copy paste for the moment. Don't need that.
I think the finish will return negative if it fails.
Oh yeah. Hang on, let's check. It looks like it's returning PyObject pointer.
Oh. Oh no, okay.
Yeah. So null is correct. So we want like this.
Oh yeah.
Oh, it's probably giving a reference, isn't it?
Oh, it's giving us. Oh, that's giving us a PyObject. We don't want that.
What?
Yeah, get rid of the PyUnicode writer. We want the buffer itself.
But what does PyUnicode writer?
Now that constructs a PyUnicode object. Want to get rid of that. Just want the underlying stuff.
Oh, is this what's PyUnicode result? Putting it PyUnicode get length. Yeah. It's some, yeah, okay, we don't need that really, I don't think. So we could instead just do, what do we do with the writer? We do.
Where are you?
Looking at the PyUnicode writer finish to see what we do instead. Do write a buffer. Doesn't look like we, because the PyUnicode writer is just a struct, is it? We don't need to deallocate it.
Yeah. Well, we don't need to deallocate it. We need to finalize it somehow.
It's just an inline structure, so I think we can just probably ignore it. Just checking. Let's go back to fill data or abort.
Yep.
So I think with the writer, we can do that. We can do the decode. And then I'm going to pretend we don't need to do anything here. And we just forget about the struct. Because I don't think it holds any references or anything.
Right, yeah.
So with that, then we hopefully are in a better place.
Well, remove the Unicode writer.
So
But just
don't
the
we?
start on it. Oh,
We've now done the decode.
yeah, remove the writer.
Remove
There,
just
that block. No, no, no. The first one of those two. That one.
oh, we don't want to do a mem
Yeah.
copy. Yeah. What does this init with buffer do?
And that's where you give it a buffer.
That looks okay.
Yeah, we probably need to. Okay, so what the Unicode writer does is it holds the buffer and will reallocate it when necessary. And the decode routine is wired to the Unicode writer.
Yeah.
So maybe what we want to do is keep the writer, but then instead of finishing to get a Unicode object, we need to finish it and get the buffer out of it. Assign that to our object.
Because init with buffer. Yeah.
That?
Yes, that looks like the right thing to do. And we could just take the ownership of the buffer. We don't need to do anything. Yeah.
Wait, what is that buffer there? Is that
That's come from the
a Unicode object?
I thought it was. It was U, which was a new Unicode. Let's go look in Unicode Writer. Unicode Writer dialog. Which clears the buffer. Yeah, so it does look like it holds a reference to something.
Look at Unicode writer finish.
Yeah, that is taking
what does that do?
It checks the buffer to check whether it's
I didn't write anything. It
please
goes
excuse
empty.
doorbell, but I'm sorry about that. Yeah, this is it's taking the string object out the Unicode object out of the buffer. It looks like the buffer is expected to be a Unicode object that it's writing to.
Yes.
Which
I think the safe thing to do is give this a new Unicode object. Let it do its thing, and then copy the buffer over to our object and take ownership of it. I don't know what kind of invariance it wants on this Unicode object.
Yeah, that seems wise.
Probably not safe to give it something that's already existing.
So we probably want this, and I'm guessing that the length is a hint.
Yes.
So why don't we... Okay, so we'll go back here. So we have writer, Unicode writer create.
The create will allocate it on the heap. You probably want an internal version of that.
Oh yeah.
Unicode writer init. Core.
Okay, yep. Okay, yep. Like that. And that's probably going to be good enough. Now we'll use the writer. I guess that error handler is that. Errors is this.
Mm-hmm.
Consumed is presumably 0.
Yeah.
We should probably go check. Consumed. Oh, it's an out pointer.
Ah, right.
That's fine. We probably don't need it. Let's just put it to null and see what happens. No, I put that in the wrong place. Here. Null. Hope that that handles it fine. If not, we can. Okay, so we'll
Don't
need.
need to worry about deallocating the writer.
Yep.
Crashing anyway. And now we have.
Oh, we probably do. Oh no, because we're
That's
crashing
the
anyway.
other
Fine.
part we're crashing.
Yep.
So now in writer we have the Unicode object, and we want to call Unicode writer finish, right?
I think we just want to steal the buffer out of the new object and then clear it. I think we want some evil like Unicode object take data.
Yeah.
So I think we will do buff. Oh yeah, we can do this. Cast it to a code object. This. And then we can do.
So that we Unicode writer into.
And then decoded the other way around now.
Coded.
Copy, coded. Oh yeah, thank you. Data.lazy any. Think. Oops. Right.
Yeah.
And now we can do date.
And so the size as well.
Oh yeah. Or the kind, yeah. That one. And then
Size, and you need to set the size to write or pause. The decoded might be over allocated. So Unicode writer finish will trim the object if it's deallocated.
Put me, where am I editing?
I can't see the line number.
Sorry. Up we go.
2106.
2106.
Unicode arrow, I don't know, size or something.
Yeah.
The lazy len or something like that.
I think there was a lazy length, yes.
Yeah, lazy length equals writer arrow pause.
Okay.
Yep.
Right. Let me think about that. Because you're saying
Now
that is the... And then there's an allocation. We don't know... We don't need to right size the allocation, do we? Good.
Oh,
We assume the writer's done a
yeah, I
job.
guess yes, we need to do that.
So there, that is PyUnicode
How is
writer
that
finished.
allocated? Well, we can just call the PyUnicode resize compactor.
Oh, okay.
What the PyUnicode writer does.
Yeah. I guess we could do finish. That would basically take the object out of the buffer and do the resize. It would also have the... Oh, no. It needs to be... Oh, there's a special case where it's empty. Well... Oh, but no, we shouldn't ever hit that here. Okay, I think we'll just do this. Yeah. I think. Maybe PyUnicode writer finish. Fine to call. Let's do that. Let's just call PyUnicode writer finish. That feels like it's less plumbing around with internals.
Well, underscore PyUnicode writer finish is internals.
Well, but we're going even more into like internals of the writer. I think we can just do this. And then we don't need to clean up the writer, and we know that it's right-sized and all that kind of thing. Is what I'm thinking.
Well, that will give us a strong reference to the decoded object and
I think we need to throw it away anyway, right? So
heal from that.
yeah. I think this is what we want. And then we can... Now we can... Yep, so now we're going to want to do PyDecref coded at the end. The question is...
But before that, we want to set its lazy any to null.
Yes, I think so.
Hopefully, the allocator will handle that.
It hopefully already has, because we must have dealt with that when we were... we must have dealt with that when we did the other thing.
Hopefully. You know, 1208, that's line 1208. You want to that one.
It should look like this. I guess we should do all of these together. Decoded lazy state. Find equal. Started it with. And we probably want to set the lazy length to 0.
Try that.
I'm just going to check what we set it to. Yeah, 0 and 0. The lazy length was -1.
Lazy length -1. Okay.
Lazy kind of 0. We'll do that. Let's see what happens.
Oh. Yeah, line 1208. Do that. Line 2108, sorry.
2108. Oh, yep. That can definitely go.
Oh, from the writer.
Yeah, I guess we could also have a way where the writer filled the
That's
one we
a
had,
bit
but
dangerous.
that's more complicated, isn't it? This is a backwards compatibility path in the long run, I guess. 093 Unicode decode UTF. I must have things upside down.
Right.
Yeah. Maybe we forward declare this one. Or we move it down. Down. Let's just put it at the bottom.
Forward declare is probably best to do.
Forward declare Unicode decode UTF-8 MPOL. This one?
Yeah.
Okay. Oh, we haven't worked out what our pointers should be. What were they? In
What
this,
is what is
S is the start, is the full string. Yeah. S is where we currently are. End is the end. S is the pointer. So I think we want we probably want it's going to be that. That seems okay. Yeah, that's Copilot's just done it. That's what I expect we need. Point to the buffer. The 2 pointers I think are equal, and then the end is the start plus the length. Let's try again. Okay. Apparently we have. Oh, we still have our old branch that we don't need. We're getting there. Oh, yeah. Let's be in. Need a cast, I guess.
So Unicode state should give you the cast.
Yeah.
For the data, and that's all you need.
We need it for.
Oh, for the lazy line.
Oh, this is. We're going to need it for these ones, aren't we? Which is okay because we can use Unicode data any coded, and we can use Unicode length
Right.
coded. That should be okay. That should work. And
there again.
Set data any decoded. Oh, gonna do the same thing for length, hopefully. What does the... Oh, that one is a... We could use that one. Okay. I think that's going to work. Okay, we're close. We have 2111.
Op and out here.
Oh yeah. And no, op is a Py object. Data. Oh, we could use the macros again, yeah. Oh. Yeah. Oh. Looks promising. Oh.
Oh.
It's the same point where we crash. Okay.
Unicode fill data our board uses for the UTF-8 decode. Target escape.
So it's getting to this point and it's crashing. I wonder whether hang on. One 173 plus. I suspect that it's the null we put in. Maybe. Best plus.
So that should be.
Oh no, yeah.
That should be handled. Isn't. Oh, it's not guarded here. Okay, just give it an address too.
I think we probably want to give it yeah. What's the it's a PySID. Hopefully that's going to solve it. So that was the one thing where we tried to take a shortcut and the shortcut bit up.
Let's find the other place where we tried to take a shortcut.
Oh, yeah, there's still others. Or it's maybe the same one. Yeah, it's still crashing at the same point. So we're going to have to think about this a little bit harder.
Was it enough streaming for the day, by the way?
Oh, yes, we are close to time. I guess that's a good place to stop. Shall we? We are running out of time, aren't we?
Fine. Obvious where we need to continue. The
okay.
mate doesn't work.
This
crashes.
Is crashing. All right. Yeah, let's pause there then. Right. Well, that was good fun. We got close. We remembered how to benchmark. And then we found that in the process of optimizing, we needed to fix our shortcut. So I guess next time will probably be towards the end of September if we're resuming our usual schedule after the school holidays, and I think that seems fine. That's probably going to make it the 25th of September looking at the calendar, but we can catch up about that and be a little bit more orderly ahead of time. Cool.
Yeah, well, let's do that.
Let's stop the stream here. So thanks everyone for joining on YouTube. Good rest of your day.